Hey guys, so today during class I said that I would make a video going through the back page of this review packet. So I'm going to go through these. I'll try to make some maybe notes as I go through. If there's other things, remember, if you need help studying, I'll be after school today, which is Tuesday. I'll be after school tomorrow, which I know for some of you it might be today, but is Wednesday. But your test is the next time that I see you in class. So in my Blue Day classes, I went through and wrote these things anyways. Let me repeat kind of what's happening. For 40 and 41, it's asking the question, determine if f is continuous at the given number. And we said that in order for a function to be continuous, the function has to be defined, the limit has to exist, and the function value has to equal the value of the limit. And this is the notation that it would look like. So for instance, if we were doing continuity at x equals 3, it would be f of 3 equals the limit as x approaches 3 of f of x. Remember, if any of these things break down, if my function isn't defined, so remember, for a function value, if I get 0 over 0, that's not defined. For limits, we have magic we can do, or mathemagic with 0 over 0. We can factor, we can rationalize. That's only if it's a limit. For a function value, 0 over 0 is not defined. So if my function's not defined, I stop. I'm not continuous. If my limit doesn't exist, I stop. I'm not continuous. If the values aren't equal, I stop. I'm not continuous. So let's go through these processes and see what happens. So for number 40, the first thing I'm going to do is determine what is the value of my function at 1, because 1 is where we're determining if it's continuous. Well, since this one has the equals, I'm using this part of the function. So I have 1 plus 1 squared. It's going to give me a value of 2. So that's my function value. My function's defined. I have a numerical value, so I can move on to step 2. You guys have to label your steps. If I have to search for things, that's a problem. On the AP Calc exam, for those of you who are going to get there, you're going to have to show all these steps. So let's look at number 2. Now I need to determine if my limit exists. Well, this one's tricky because my limit from the left, or the function on the left side of 1, is not the same as what's happening after 1. That means I need to do the limit as x approaches 0 from the left side. This is the before. And I need to do the limit as x approaches 0 from the right side. This is the after. If I have the inequalities in my piecewise function, I have to do the before and after, and I need this good notation. You're going to lose points without this good notation. Okay? Well, there's no real problems here. I'm just going to substitute in 0. It's going to give me 1 plus... oh, guys, I'm sorry. I made a mistake real fast. Not 0, we're doing it at 1. So 1 from the left and 1 from the right. I'm sorry. Because we're figuring out if it's continuous at 1. I don't know why I picked 0. Okay, so I'm going to plug in 1. That's going to give me 1 plus 1, which is 2. I'm going to plug in 1. I'm going to get negative 1 plus 3. Okay, that's 2. Well, if the limit from the left is the same as the limit from the right, then my limit exists. I'm not going to make you write that statement, but I do know that my limit exists, so I can move on to step 3. And step 3 is asking the question, is the value of my function equal to the value of my limit? Well, in this case, it is. So it says determine if f is continuous. We're going to say yes. F is continuous at x equals 1 because the function value, f of 1, is equal to the value of the limit. Okay. Now, if you look at a lot of textbooks or sometimes other teachers, like, oh, a lot of times step 1 is this, step 2 is this, and step 3 is only going to be that statement. You're either going to say yes or no for that statement. But I like to put my justification all in one place. I just find that easier. It just saves me a little bit of time. So let's move on to number 41. Remember, to figure if it's continuous, I start to figure out if my function's defined. Some of you guys have a typo on this. I tried to fix as many as I could. This should have an equal sign here. Many of them have the does not equals, mostly in 5th period. So now we're going to do my function. Well, wait a minute. At 1, the function has a value of 5. We didn't have to do much work there. Okay, step 2. Now I'm going to do the limit. Well, notice this is the at. This is anywhere where it's not 1. So this is going to be before 1. This is going to be after 1. So I can just do the limit of x cubed all at once. Remember, when I do a limit, we do it of the does not equals part. Okay, well, I'm going to plug in 1. I'm going to substitute. And I get a value of 1. So wait a minute. Step 3 is when I determine if these parts are the same, and we can tell that they're not. So I'm going to say, this is where my breakdown happened. So I'm going to say, no, f is not continuous at x equals 1 because f of 1 does not equal the limit as x approaches 1 of f of x. As soon as my step breaks down, I write my no statement and I say, why not? If my problem was step 1, I'd say, if this was undefined, I'd say no because f of 1 is undefined. If my problem was here, I would say no because the limit as x approaches 1 of f of x does not exist. Here it was no because the values weren't equal. But if the values are equal, we get already there. We say yes because the values are equal. So please make sure you're labeling your steps. So 1, 2, 3. Now remember, if you stop at step 1, you don't have to do step 2 and step 3. But if you make it, you need to label all of them. That's how we do continuity. A reminder, on the quiz and also on the cards we did in class, we had a lot of problems where we stopped at step 1. Remember, for functions, a function's not defined if you get 0 over 0. Limits we can mess with 0 over 0, but we can't for function values. Okay? Again, come find me after school if you guys need help with this. Let's get down now to number 42 through 44. These are intermediate value theorem problems. And they're normally going to be phrased in the way of saying, are we guaranteed a value C such that? Or is there a time when? Things like that. Okay, well, in order to use the intermediate value theorem, I have to know that my function is continuous. I start by saying f of x is continuous on 0, 3. That's my question. It's either a yes or a no. Well, this is a polynomial, a linear, a quadratic, cubic. Those are all polynomials. So that's step 1. Is it continuous? You don't have to label your steps for intermediate value theorem. This is more just to help you think through what you need to do. Now I need my y values at the endpoints. My endpoints are at x equals 0 and x equals 3. This is an interval of x values. So I'm going to figure out what my y values are at these values. I'm going to plug in 0, and I'm going to get 0 minus 1. If I plug in 3, I get 6 minus 1. So my y values are negative 1 and 5. So step 3 says, is the y value that I care about in between them? Because it says, are we guaranteed a value C such that f of C equals 1? Am I guaranteed a time when y is 1? Well, wait a minute. Since 1 is in between negative 1 and 5, I have to pass through a y value of 1 because my function is continuous. So are we guaranteed a value C? I'm going to say yes because 1 is between negative 1 and 5. We could also say yes because 1 is between f of 0 and f of 3. Sometimes it's going to ask you to say, if so, solve for C, but this problem does not ask us to solve for C, so I don't need to. So let's do 43. It says, is there a 0? This is just really asking the same question up here. I'm asking, is there a C value such that the y value is 0? It's the same problem. We're just seeing if there's a 0. So the first thing I need to figure out is if my function is continuous. Well, this is a polynomial, it's a cubic, so it is continuous. I have to make that statement. If a function's not continuous, I can have a jump, so I might not cross through my y values. Step 2, I need to figure out what my function values are at the endpoints, what the y values are. So if I plug in 1, I'm going to get 1 cubed minus 5 plus 1. That's negative 3. Oopsies, that's a funny looking 3. Whoa. Let's wipe that out and try again. Got even worse. Okay, now let's plug in 3. 3 cubed is 27. 5 times 3 is 15. So 27 minus 15 is 12. 12 plus 1 is 13. So my y values at my endpoints are negative 3 and 13. So if I were to actually sketch a picture, I'm saying at 1, I have a value of negative 3. At 3, I have a value of 13. Well, if it's continuous, the only way I can get from here to here, I don't really know how it's going to curve or what, but I have to eventually cross the y value 0. That's what it's saying. So my answer is going to be yes, because 0 is between -3 and 13. So remember, step 1 is it continuous? Okay, what are my y values and my endpoints? Is the value I want in between. So yes. Sometimes, again, I'll say find C. This one didn't ask you for it. If you look at your notes, you find examples like that. Okay, so here's lastly number 44. It says a marine biologist measures the depth of a stream at a point heavily populated with fish. The river is 16 feet wide at this location. The measurements are taken in a straight line perpendicular to the edge of the river. The data is shown in the table below. Does the data in the table support the conclusion that the depth of the river is 23 inches at some distance from the stream edge between time equals 3 and time equals 6? Give a reason for your answer. So I'm going to immediately just say I only care about what's happening between time equals 3 and time equals 6. Well, at time equals 3, the depth is 12 inches. At time equals 6, the depth is 22 inches. So the question is, am I guaranteed that at some point in between then that I'll have a depth of 23 inches? Well, the answer is going to be no, because 23 is not between 12 and 22. Okay? Now, we would have to cross through a value of 13, 14, 15, 20, 21, but not 23. It's outside. It's possible that the depth of the river is 23, but we're just not guaranteed that it will be. Okay? So those are those 5 problems for you guys. I hope you find this helpful. Again, please come find me if you need help. Remember, if your quiz was below an 80%, you can do corrections, and if your test grade is better, we'll write over your quiz grade up to an 80%. So good luck studying, guys. I'll see you soon.